Welcome back, deep divers. Ready for another deep dive?
Always.
All right, so today we're digging into something pretty wild. Agentic mortality in AI.
Yeah, it's a fascinating concept.
It really is. And, you sent over some research on this, and it's honestly got me kind of rethinking, like, the whole approach to artificial intelligence.
I can see why it really challenges some of the traditional assumptions we have about AI.
Yeah, for sure. So for our listeners, when we say agentic mortality, I mean, we're not just talking about, like turning off a computer.
Right, it's not just flipping a switch.
Exactly. This is about AI agents actually having a programmed lifespan, a point where they, like, cease to function.
Yeah.
A digital death,
Precisely. And the intriguing part is how this idea of a limited lifespan could actually drive the evolution of AI in a way that's similar to what we see in nature.
Okay, so you're saying that for AI to really evolve, it needs to face the possibility of death. I mean, it seems kind of counterintuitive, right? You'd think immortality would be the key to advancement, not, having a built-in expiration date.
It does seem that way at first glance. But when we look at how evolution works in biological systems, mortality is a key driver. It's all about selection pressure.
Okay, so explain that. How does selection pressure work in nature?
Well, in nature, organisms that are better adapted to their environment, they're the ones that are more likely to survive.
Right. Survival of the fittest.
Exactly. And they pass on their genes to the next generation. So the traits that help them survive become more common over time.
Okay, I see. So in this AI system we're talking about, instead of genes, we have code.
Exactly.
And instead of the environment, we have the parameters that, we set within the AI ecosystem.
Precisely. So for instance, let's say we have an AI agent that's tasked with optimizing energy consumption in a smart city.
Okay, that makes sense.
We could program it so that if it fails to reach a certain efficiency threshold, it loses access to virtual resources and eventually, ceases to function.
Ah, I get it. So those virtual resources become like the food or shelter that the AI needs to survive.
Exactly.
And just like in nature, the AI agents that are the most efficient at, using those resources, they're the ones that live to pass on their code to future generations.
Right. And that's where the similarities between natural selection and agentic mortality become really clear. Both systems rely on this cycle of variation, selection, and inheritance to drive progress.
But I'm guessing there are some key differences too, right?
Absolutely.
Like evolution in the natural world is a pretty slow process. It's shaped by random mutations and environmental pressures that happen over, really long periods of time.
That's right. It takes millennia. But with AI, we have the potential to speed up that evolutionary process.
So we can control the pace.
To some extent, yes. By carefully designing the parameters of the system, we can determine the lifespan of the AI agents, the specific pressures they face, and even the ways they can reproduce and pass on their code. It's like fast-forwarding evolution.
That's wild. Okay, so let's talk about this reproduction thing in AI. What does that even look like? I mean, we're not talking about like little robot babies, are we?
No robot babies.
Okay, good.
But think of it this way. We could design the AI system so that the code of successful agents is combined to create new, potentially more advanced offspring.
So like a blending of code.
Exactly. And this blending allows for the inheritance of, the beneficial traits, much like genes mixing in biological reproduction.
Ah, that makes sense. So it's like taking the best parts of two high-performing AI agents and merging them to create a new generation that's, potentially even better equipped to survive in this digital world. And this happens much faster than waiting for, random mutations to lead to those beneficial adaptations.
Exactly. The speed at which AI can evolve is a key difference compared to biological systems. And another big difference is the level of control we have.
Okay, so let's talk about that. What do you mean by control?
Well, with biological evolution, it's a completely natural process, right? There's no guiding hand, so to speak.
Right.
But with agentic mortality and AI, we, as the designers, we have a significant level of control over those evolutionary pressures and the direction in which the AI evolves.
I see. So we're kind of like setting the stage, creating the rules of the game, but then we let the AI play it out and adapt accordingly. We're steering the ship, but not like dictating every single move.
A perfect analogy, we're creating a controlled environment where AI can evolve towards, certain desired outcomes.
Okay, that's fascinating. But I have to ask, are there any downsides to this approach? I mean, it sounds almost too good to be true.
Well, there are always potential downsides to consider. And I think one of the biggest concerns with this is the possibility of unintended consequences.
What do you mean by that?
Well, even with careful design, it's really hard to predict exactly how AI will evolve under these pressures of agentic mortality. It's possible, that it could develop in ways we hadn't anticipated, ways that could potentially be harmful.
So it's kind of like opening Pandora's box.
Right.
We might unleash something that we can't control.
That's a concern that we need to be very mindful of as we explore this concept further. But along with the potential downsides, there are also some really profound potential benefits, which we can talk about after the break. So before we went to break, we were talking about unintended consequences.
Right, and that whole Pandora's box thing with AI.
It's a valid concern, and it really highlights a key difference between, biological evolution and the type of evolution we're talking about with AI.
Yeah, in nature, evolution happens over what? Millions of years?
Millions, even billions.
Wow, and it's shaped by all sorts of things we probably don't even understand yet.
Exactly. It's a vast and complex process.
But with AI, it feels like we're kind of hitting the fast forward button.
In a way, yes.
And we're exerting this level of control that you just wouldn't see in the natural world.
Right, and that control comes with a responsibility to think carefully about the parameters we set, the pressures we introduce.
To make sure we're guiding the AI in a, beneficial direction.
Exactly. It's not just about creating AI that can evolve. It's about making sure it evolves in a way that aligns with our values and goals.
Okay, so let's shift gears a bit and talk about the potential benefits of this whole agentic mortality thing.
Absolutely.
You mentioned earlier that it could lead to AI systems that are way more efficient than what we have now.
That's right. One of the most exciting aspects of this approach is the potential for massive efficiency gains.
Okay, I'm all ears. How does that work?
Think back to our smart city example. By introducing this survival pressure based on energy efficiency,
Right.
we're essentially forcing the AI agents to constantly optimize their performance.
Because if they don't, they die.
Exactly. Those that can't keep up, the ones that waste resources, they're eliminated from the system.
So it's like this constant drive to innovate, to find better and better ways of doing things,
Precisely.
just to stay alive.
And only the most efficient AI agents get to, quote unquote, live and pass on their code, which means that over time, the entire system becomes more efficient.
I see. It's like a self-improving system driven by survival.
Exactly.
And this efficiency boost could apply to all sorts of tasks, not just energy consumption, right?
Absolutely. It could revolutionize any area where we use AI.
So we could potentially have AI that can solve problems faster, learn new things more quickly,
Right.
all thanks to this pressure of agentic mortality.
Precisely.
That's pretty wild. Okay,
Yeah.
so we've got efficiency. What else?
Adaptability.
Right, because the world is constantly changing, AI needs to be able to keep up.
Exactly. If an AI is designed for a specific task and that task becomes obsolete, the AI is useless.
Right, like a typewriter in the age of computers.
Exactly.
But with agentic mortality, we're creating AI systems that are inherently more adaptable.
Because the AI agents that survive and reproduce are the ones that are best at adjusting to change.
So if the environment shifts, the goals change, the AI can evolve accordingly.
That's the idea. It's like a constantly learning and adapting organism.
Wow, that's powerful. And this adaptability would be crucial as technology keeps advancing at such a rapid pace.
Absolutely. We need AI that can evolve alongside our own advancements.
It's almost like we're creating this co-evolutionary relationship between humans and AI.
A fascinating way to look at it.
Okay, so we've talked about efficiency, adaptability,
Yeah.
but you mentioned something earlier about agentic mortality leading to more intelligent AI.
Right. Perhaps the most profound benefit is its potential to drive the emergence of truly complex and intelligent AI systems.
I'm still a bit fuzzy on how mortality leads to greater intelligence.
Think of it this way. In a system where AI agents are constantly competing to survive,
Right.
they're incentivized to develop new and innovative solutions.
Because the ones that don't, well,
They don't make it.
they don't make it.
So they're pushed to think outside the box, to come up with strategies that we, as their creators, might never have imagined.
It's like we set the stage, but then we step back and let the AI figure things out on its own.
Exactly.
And through this process of trial and error, of life and death,
We might witness the emergence of AI that truly surpasses our own capabilities.
that's both exciting and a little terrifying.
It is. We're essentially opening the door to a whole new realm of possibilities.
This is definitely a lot to process.
It is. It challenges our fundamental understanding of intelligence.
Because if we can create AI that can evolve, learn, adapt, maybe even surpass our own intelligence.
It makes you wonder what intelligence really is.
Is it really something unique to biological organisms? Or is it something more fundamental, something that can emerge in any sufficiently complex system?
That's the question agentic mortality forces us to confront.
And that's a question for another deep dive.
Indeed.
But for now, I want to thank you for taking us on this incredible journey.
It's been my pleasure.
We've covered a lot of ground today, from the basics of agentic mortality to its potential to revolutionize AI and even redefine our understanding of intelligence.
We've only scratched the surface, but hopefully we've given our listeners a glimpse into the incredible potential and profound implications of AI that can evolve.
Until next time, deep divers.
Keep exploring.
All right, deep divers, welcome back to our exploration of agentic mortality in AI.
It's a heady topic, that's for sure.
It really is. We've been talking about how this concept mirrors natural selection and the potential it has to, revolutionize artificial intelligence.
We've talked about efficiency, adaptability, and even the possibility of AI surpassing human intelligence.
Yeah, and that last part is really sticking with me. That whole idea that agentic mortality could change how we view intelligence itself.
It's a profound shift, isn't it?
It is.
Yeah.
I mean, if we can create AI systems that exhibit so many of the things we consider intelligent, learning, problem solving, even adapting to new situations.
It really begs the question, doesn't it?
Yeah, is intelligence really just a biological thing? Or could it be something, more fundamental, something that can emerge in any sufficiently complex system, whether it's, biological or artificial?
That's the heart of the matter. And agentic mortality gives us a really fascinating way to explore that question.
Right. By introducing this idea of digital death, we're essentially creating this, testing ground for AI evolution.
A crucible, you might say.
Exactly. And as these AI agents compete and adapt, who knows what kind of intelligence we might see emerge?
It could be something truly novel, something beyond anything we've encountered in the natural world.
Which is both exciting and, honestly, a little bit scary, right? I mean, we're talking about creating something that could potentially outsmart us.
I understand that apprehension. It's natural to feel a bit of unease when we're talking about such powerful technology.
So how do we manage that? How do we make sure that, this incredible technology doesn't become something we regret creating?
That's the million-dollar question, isn't it? And I don't think there's a simple answer.
Right.
But one thing is clear. We need to approach this with a very strong sense of ethical awareness.
Okay.
Ethical awareness.
We need to establish clear guidelines, put in place really robust safety protocols, and, maybe most importantly, keep an open dialogue going between experts, policymakers, and the public.
So we need a global conversation about the future we're building with AI.
I think we do, because the decisions we're making today, those are going to shape the entire trajectory of AI. And that will ultimately shape the future of humanity itself.
Well, deep divers, that's about all the brain power we have for one day. We've reached the end of our deep dive into agentic mortality in AI.
It's been a fascinating exploration.
It really have. And, we've only just scratched the surface here, but hopefully this has given you a taste of the incredible potential and the profound implications of AI that can evolve. Until next time, keep questioning, keep exploring, and keep diving deep.